Hey everyone, welcome to the very first video on my channel. And today I want to talk about a piece of technology which is a bit close to me, as in I really love working with this piece of technology, and that is Linux. Now, before I go into what exactly is Linux, I want to first cover a few different topics which at first may not seem related, but they will help you understand what is Linux. So let's get started. Alright, so the first thing which I want to talk about is how does your computer actually work? Now, just for the sake of familiarity, let's assume that we're talking about a Windows machine right now. So how does it work? Let's see. So before anything, before you boot on your computer or any of that, you need some hardware, right? Whether you have a laptop, whether you have a desktop PC, it all works with some sort of hardware. Correct. So we have this one layer of hardware. All right. So we have a bit of hardware. What does this hardware include? This includes things like a CPU. It includes some RAM or memory as we call it. It has storage devices. Now, depending on your system, you may or may not have a graphics card. Actually, every single computer has a graphics card in some sense, but there are different ways on that. We won't get into that rabbit hole just yet. All right, so we have this hardware layer. Now, in order to do anything, for example, right now I'm running a Chrome window on my screen here. So in order to do that, this Chrome window at the end of the day has to somehow interact with the hardware, right? Now, I can probably do something like have my Chrome window talk directly with my hardware, correct? That should be completely possible if we're thinking from a programmatic standpoint. But here's a caveat. I as a developer of something like Google Chrome or a different application will need to figure out exactly how to make Chrome talk with my hardware. And then I need to also make sure that my design considerations take into account that I will be running some other applications. So let's say I could be running something like Discord. I could also be running something like Slack, correct? And all of these would then be using the same way to interact with my hardware, which is directly. So they all will probably have their own different implementations. Now, you can probably see what's wrong with this. Chrome might be using one certain implementation, Discord would be using a different implementation, and so on. And all these different implementations will probably conflict with each other, and everything that's running on my computer will run into some kind of bugs, correct? Now, let's understand how all these things are actually done. Now, how how all these applications actually interact with the hardware is through something called as a kernel. So your kernel will be sitting right on top of your hardware, right? So your kernel is what will actually talk to the hardware. Now, in order to understand a kernel is just a bunch of functions and system calls which are used to talk with the hardware and get certain resources from the hardware. All right. So if I'm talking in terms of Windows kernel, I'm not exactly sure what does the latest version of Windows use as its kernel, but legacy Windows systems such as Windows 7, Windows XP and earlier used something called as DOS as its kernel. So this was the software which talked with that hardware and created what you knew as Windows. Today it might be DOS itself, but as far as I'm aware, they have updated the kernel to something a bit more modern, a bit more robust. Now on top of this kernel is what you know as your operating system or your OS, right? So this could be Windows, this could be Mac OS. So your operating system at the end of the day, it will talk to the kernel will then go ahead and talk to the hardware, and finally the hardware will send back whatever system resources required, and the kernel will determine how the operating system and various applications running on top of the operating system should receive all these system resources. So we took the example of three apps earlier: Chrome, Discord, and Slack. So let's just get two of these applications, Chrome and Discord. All right. So these will run on top of your operating system, correct? So the operating system basically talks with the kernel, and the kernel assigns resources to these applications running on your system. Now, the Windows operating system, Mac OS, Linux all run in this exact same way. So why am I talking about kernels right now? Linux is not really an operating system. Linux is a kernel. So this layer which sits between your operating system and the hardware, that is what Linux is. Now I have something which can help you visualize all the different functionalities that the Linux kernel has. So this is one really fun interactive Linux kernel map. So in this you have every single system call that exists within the current Linux kernel. It's just a GitHub repository that has all these things. So for example, I'm developing something low level. Let's say I'm developing an application, a video game. So in a video game, I need to be able to interact with the kernel directly and make things as optimized as possible, right? I need to make it as fast as possible. So I will come over to this Linux kernel map, and let's say I want to figure out how to manage something in memory. So using this map, I can look into something like si/meminfo. I click on it, and then it will take me to this documentation page where I have all the information about this particular system call, right? So this is a really useful resource. I will link this in the description so you can check it out. All right, so now you understand what is a kernel, and now you also understand that Linux at the end of the day is a kernel. So now you might have this, if you have explored the Linux ecosystem a little bit, you might have come across things such as Ubuntu, Fedora, Arch Linux, and other things, right? So you might have this question. So are these things not actually Linux? Well, they are Linux, but a very big but. They all use the Linux kernel. All right. On top of the Linux kernel, the way these different things, the way Ubuntu, Fedora, or Arch Linux implement things above the kernel level is different. So that is a major difference between all these different Linux based distributions. So you have the kernel, this kernel goes through some sort of modification, and on top of it you have different ways how you would do a couple of things. So that's how you create a Linux distribution. At the end of the day, you're using the same Linux kernel with a couple of tweaks. Ubuntu has a couple of tweaks. Ubuntu specifically uses something called as snaps. So that is the specific flavor of Linux that Ubuntu uses. Fedora uses something completely different, right? Arch Linux uses something completely different. So it's all Linux. The core concepts are the exact same, but the way the high level things are implemented differs at some level. If you know how to use something like Arch Linux, then you pretty much know how to use something like Ubuntu or Fedora or Debian or pretty much every other distributions. Eventually, there do come some distributions that do things uniquely, such as NixOS, but that is a completely different conversation. Now, I want to talk about how you can actually get started with Linux. So there are four ways in which you can get started with the Linux distribution. Number one, you dual boot it, or you wipe out your existing operating system completely and you have just a Linux based distribution. Now, personally, this is my favorite method of using Linux because it teaches you a lot more than any of the other three methods can show you. The second method is a virtual machine. Now, I'm in this particular video, I'm not going to go deep into what is a virtual machine and how it works. But the TLDR is an operating system running on top of your existing operating system. That is the second way, and this is, I will show you how to do this. The third method is using a technology called as WSL, or Windows Subsystem for Linux. Now, this has its own documentation page, and it is essentially a virtual machine, but not quite. It's a little confusing to explain in this video itself. So if you're interested with what is WSL, I can make a separate video about that. Just let me know down in the comments. And the fourth method, which is also one of my favorites, is running it in a cloud playground. So right now I want to show you how to use a virtual machine and a cloud playground. Let's start with the easy one, which is using a cloud playground. So here's a website which I really like for creating cloud playgrounds of Linux and a lot of different tools. So you can see here that there are a couple of certification playgrounds. There's a lot of tools which have their own particular playgrounds. But right now I want to talk to you about how you can set up a Linux playground. So you come over to this website, killercoda.com, and you head over to the playgrounds. Let it load, and what you can do is you can start a Ubuntu playground. Just give it a couple of minutes. You can sign in with one of your accounts. I usually love using GitHub. And then right here you have a Linux environment. So in here you can run Linux commands, whatever you want. All right. Don't worry about what these commands are. I'll make couple of different videos explaining these different Linux commands and showing you hands-on as well. All right, so this was the simple way, which is running Linux within a cloud environment. Now, the second thing which I want to show you is how you can run it in a virtual machine. So in order to run Linux within a virtual machine, you're going to need a piece of software called as a VirtualBox. Now, this VirtualBox was created by Oracle, but I'm not going to get into all of that. Just install this and I will show you how you can actually create a virtual machine. Apart from this VirtualBox, you're also going to need a ISO image of a Linux machine. So go ahead and download your favorite Linux ISO. I have an ISO of Arch Linux installed, and I'm going to use that. Now, don't get intimidated just because I'm saying Arch Linux and because you've heard that this is a very advanced distribution. Don't worry about that. In this particular video, I am just showing you how to use VirtualBox. The steps for using any other distribution on VirtualBox are the exact same. All right. So here I am in VirtualBox. Now I already have an Arch machine here, but I'm going to get rid of it. And now I'm going to show you how you can create your own little virtual Linux environment. So I want to come here and click on new. And I'm going to just give this new virtual machine a name such as Arch. And now I need to select an ISO image. So I'm going to navigate over. Oh, all right. So instead of navigating, I already have my Arch Linux ISO over here because I've used it previously. So I will just select it, and all these different things will probably get filled out on their own. But if you feel that they are incorrect, you can just come here. You can change the type of kernel it is, either the Windows kernel, a Linux kernel, a BSD kernel, or something else. And you can select which version it is. Now, I mentioned that there are a couple of Linux distribution. So take a look at this big list. These are all different Linux distribution. You have Ubuntu, you have Red Hat, OpenSUSE, and a lot others. All right, but now mine is Arch Linux, so that's what I'm going to do. Now, I also want to make sure that my hardware is set correctly. So I've got 1 GB of RAM, I've got one processor, or rather one CPU core allocated to this, which is all well and good. Now, if I come over to my hard disk, you can see that it only has 8 gigs of virtual storage, which according to me is fine. But since I'm going to be doing a lot more things on this virtual machine, I want to give it, let's say, about 60 gigabytes. 63, not exact. And over here, just select the VDI VirtualBox disk image, because with a disk image, you can use this exact same thing on different instances of VirtualBox as well. For example, let's say I install VirtualBox on a different computer. I can just copy this VDI image and I can run this exact same on that different computer which has VirtualBox. All right. Now I can do finish and my Arch Linux virtual machine has been created. Now I will simply start it and I will do a normal start, and you can see that it's powering up. Let's just give it a couple of minutes. One thing I should mention is that depending on how powerful your system is, this may take more time or less time. Alright, so this screen right here is my Arch Linux install media. So if I try to install Arch Linux manually, I would burn Arch Linux ISO onto a pen drive or something, and then I would boot from that. And this is the exact screen which I would get. So I can go ahead and say that I want to install it, and it'll run all its startup checks, and it'll get me to the installation menu. So let's just give this a couple of seconds to load, and there we go. Now this is the install menu for Arch Linux specifically. I'm not going to show you how to install Arch Linux in this video. I have made an amazing blog, at least I think it is a really good blog on how you can install Arch Linux and get started with it, and I'll link that in the description as well. And you can refer to that if you want to learn about Arch Linux specifically. If you put in an Ubuntu image, this will take you to Ubuntu's guided graphical installer, which is, and then you can find tutorials on how to install that on the internet. There are tons of tutorials on that. Alright, so before I end this video, I want to give a shout out to my friend Leon. So he has this really nice GitHub repository, which he and I decided to start, but both of us were busy, so we couldn't get around to doing it. So what this GitHub repository, what the idea behind this GitHub repository was, is that we wanted to make small bite-sized Linux content. So everything that you have learned through this video, you can go and add it within that repository, and even you can get a couple of GitHub contributions. Now, in our the benefit that you will get from this is you will be learning Linux. First of all, you'll be learning it from this video. You'll be solidifying your own knowledge, and you'll be sharing it with the community as well. Now, all this knowledge that you put in there, sure, it is very beginner level of knowledge, but you might have some veteran Linux folks who just want to brush up on their memory, so they could go ahead and read it from there, and you would have played a hand in giving them all that information which they want, correct? So just feel free to check out that repository and contribute it to it as well. And I'll be making more videos in the future, and you can put all of that Linux knowledge into that repository. All right, so that's it for this video. I hope you liked this video and learned a fair amount from this video. I'll be making a couple more videos on Linux as well, so stay tuned for those. And yeah, I also have my own Discord community, so if you have any questions or just want to geek out with other tech enthusiasts, feel free to join it below. And yeah, see you folks in the next one.